Hello, this is fm2443. Here I'm going to introduce how to deal with the problem 2. This question shows that the random variable capital X is uniform in the interval from -1 to 1. And find gx such that if capital Y equals to g capital X, then fyy equals to e negative y times uy. So in order to solve this kind of problem, we need to set that the capital Fx equals to 1 plus x over 2, which equals to 1 minus e to the power of negative y, which equals to capital Y, y. And solve the y in terms of x. It's easy to get that y equals to negative ln 1 minus x over 2, which equals to gx 1 negative 1 less than x less than 1, and gx equals to infinity 1 x larger or equals to 1, and gx equals to 0 1 x is less or equals to negative 1. And from the equation above, we can get the figure of the capital Fx and capital Fyy. So firstly, let's draw the figure of capital Fx, x, fxx, x, 0. So we can get that 1x is larger than minus 1, 2, 1. The capital Fx should be 1 plus x over 2. And it equals to 1. 1x is larger than 1. So from the figure of capital Fx, we can easily get the figure of capital Yy. It should be like this. This is 0, y. It should be equals to 0 when y is less or equal to 0. And it should equals to 1 minus e to the power of negative y. So this is the equation of the capital Fyy. So from here, from those three equations, we can get that gx equals to 0 when x is less or equals to -1 and equals to negative ln 1 minus y over 2. When -1 less than x less than 1 and equals to infinity when x is larger than 1. We can also draw the figure of gx. It should be like this. This is gx, this is x, this is 0. It equals to 0 when x is less than 1 or -1. So it should be like this. And it equals to negative ln 1 minus y over 2. When x larger than -1, smaller than 1. So it should be like this. Sorry. It should be like this. And it equals to infinity when x is larger than 1. So this is the figure of gx. Okay, so this is the solution to find gx such that if capital Y equals to g capital X, then little fyy equals to e to the power of -y times uy. That's all. Thank you.